Okay, so what I've done is I've laid out the technical term for the 4 types of modeling that we'll explore this semester and next semester, but we will be focusing on Solidworks capabilities. And we will be focusing on how Solidworks surface models and Boolean models, which is solid body modeling. The reason I want to show you some of the other softwares is just so you have a flavor of it. You know, you may want to dive into Rhino. Rhino, you can get an amazing cost or price for a student version, and they could care less whether you use it for professional work or not. Unlike SolidWorks, where if you have a student license, they frown greatly upon anybody using it for financial gain. So, Boolean modeling, okay? Basically, it is creating solid bodies, and we'll talk about that. So, basically, picture a block of wood, and you're either going to cut the wood, or you're going to glue something to it, or you're going to sand it down, put radiuses on it. But it's really at the heart of it, adding and subtracting. Creo, Solid Edge, SolidWorks, and Fusion, Alias Fusion, all do these. This is kind of their bread and butter. This is what they excel at. There are other software packages, of course, but they're a little bit less used in the industry. Currently, right now, SolidWorks is really the industry standard. Creo or Pro-E, whatever, is out there. For example, when you work with Delta Faucet, you will see that they use Creo. If you talk to any of their industrial designers, or if you talk to Evelina, who had her internship there, she will tell you that all the industrial designers hate it and stay as far away as they can with it. Because it's not really designed for ID people. Later on, we can go into the whys in that if we ever want to. On the right-hand side of my screen, you can really see those are samples of kind of complex things that you could model using all the solid modeling features. So cuts, extrudes, revolves, things of that nature. And these are all very massive assemblies. So questions about that? Okay, so in this Boolean model operations, you really don't use surfacing. There is a state where you do get to use, Boolean modeling and NURB modeling, and what I refer to those as hybrid models, because you're using surfacing and solid modeling in conjunction to get the form that you want. We'll also learn to evaluate what you're doing to determine what are the best tools for doing it. Okay, NURB modeling. So NURB modeling, you all used SolidWorks last semester and you all learned how to do 2D sketches and extrusions and all that stuff. NURB modeling is the same, but more often than not, what you're using is referred to as B-splines or splines, which are, if you think about it old school, how many of you have ship curves that you use for your renderings or you see John Carusi pull out? No? Okay, I'm going back too far old school. So picture being able to draw a curve on a piece of paper however you want. That's what B-spline modeling is. You can see on the right-hand side, you start getting more and more complex forms. And really the way you look at this is it's almost like sculpting. Not quite, but gets there. Now, we talked about what softwares can and cannot do. All these softwares that you see down here, Creo, SolidWorks, Fusion, and Solid Edge, they have NURB modeling in there. and people will say, well, you can't do a car in SolidWorks. Well, this Camaro is a tutorial, and I can get you the tutorial if you guys have a desire next semester to be doing cars, is all modeled in SolidWorks. So I always argue with people when they say, well, you can't do complex surfaces in SolidWorks. You can. It just may take several more steps than it would in, say, Alias. If you want to change something, it may be more complex because surfacing was, for all of these, Solid Edge, Creo, SolidWorks, was an afterthought. They were designed to work with engineers and to not do those complex surfaces. It wasn't until industrial designers started needing these and surfaces became, or products became more complex. Basically, engineers could not make the concepts that were being generated that had more form to them. So they added surfacing in there. Versus software like Alias and Rhino that were specifically designed only to be a NURB modeler, a surface modeler. So therefore, that's their bread and butter. The tools they have, the capabilities that they have, differ from the other solid modelers because they looked at the solid modeling and said, yeah, we're doing this. Alias actually precedes, Alias Surface precedes any software up here. It's a power horse. I was just told that at Generac, some of them or one of their designers use Alias, and I was shocked because I've yet to ever see something come out of Generac that would require Alias. Alias is a $15,000 to $25,000 surface modeling package. SolidWorks is $6,000. Fusion, as a student or a hobbyist, if you make under $20,000 doing it, you can get it for free. And if you want to make money off of it, you're more than welcome. They don't care. That's their marketing technique to try to saturate the market. Questions? Comments? Not at this time? Okay. Oh, so let me just point out some of the things so you know. So this bottle was done in SolidWorks. There's a tutorial on how to do that, and it's really good because it shows you a lot of different things. This mouse, also done in SolidWorks. This car, Alias, could be done in SolidWorks. I guarantee you this car here done in SolidWorks, if you have equal users, so someone in SolidWorks is just as good at SolidWorks as the person in Alias, I guarantee you the person in Alias would do this in the 10th of the time and it would be more accurate and less flaws. So that's really shows you a difference in things. Also, as a side note, as students, Alias or Autodesk, you sign up for an educational license. It's free, and they give you absolute access to every single software that Autodesk makes. So if you want to play with Alias, if you want to play with Maya, which is a rendering package, if you want to play with Autodesk, whatever you want, and they're like Adobe. They've got a massive amount. So that's one of those things. Take a look, check it out. Next, what we've got is T-splines. Now, Creo, SolidWorks say they do it, but it is ridiculously, so it's basically a joke. And I'll show you later on when we look at that in SolidWorks, I'll show you how you control things as a T-spline versus, say, Rhino. But what this is basically you generate a shape, let's say a sphere, and you can pull it by dividing it into quadrants, and by pushing and pulling it, you can sculpt something. And you can see here, much more complex forms. You can go quicker because you're doing considerably fewer commands to get that same shape. The difference is it's never as dimensionally accurate. Sci-fi uses it a lot, concept artists, video game creators. Anytime you want something where you don't need it to be sent for manufacturing. You can get it dimensionally accurate within a point, but you're not going to get down to something where you're going to say, oh, I'm going to draw this on the first try and it's going to be 5.25 inches wide. And if you want to go back and change it, it's hard. Where in Solidworks, which is parametric, you key in a number and you'll get that width. So everything has a trade-off. Sub-D modeling. Very similar to T-splines. It's just basically, and I won't get into the nuance, but if you have a sphere, instead of just being able to pull the points or the faces on the sphere, it's also called cage modeling. What that means is there's an invisible cage around it. So if I have a sphere here and I've got the cage around it and I pull this corner of the cage out, that model will distort based on that as well. So it gives you a different level of refinement. And again, really complex forms, considerably quicker than doing NURB modeling with surfacing or doing solid Boolean modeling. And you can kind of see here again, a lot of concept designers, that would be extremely difficult and take an extreme amount of time to do something like that in SolidWorks. You can do the you can do kind of automotive, and again, but these are more looks like models. This would be great from a concept stage, but you can't hand that off to the engineer. So I have friends who do automotive design and automotive surfacing. And just so you know, sub-D modeling, if you get good at that, GM, Chrysler, Dodge, Fiat, they're looking for sub-D modelers. So as a student, if you get that skill, there's an in. So it's more of a looks like. This would be used as a underlay for a individual to go back and build tighter, more technical surfaces in something like Alias. Because Alias, you can then hand off to the engineers. Same as Mr. Horsey here. You can see a lot of concept shapes. If you look at this, and I said, hey, you need to make this by hand, most people would look at that and say, well, I need to get some clay. And I need to sculpt this. That's really how you can look at and consider sub-D. It's a digital sculpting tool. Okay. Questions? Everything I said was 100% clear and you understand it 1,000%. No? Okay, what are your questions, Evan? Or were you just shaking your head because of what I said? Evan.
You cut up. I didn't catch what you said.
Oh, so I saw you shaking your head when I asked for questions.
I'm shaking my head like no question.
Oh, okay. Got it.
All right.
No, that's fine. I just want to make sure that I don't move on and people are sitting there saying I'm lost. So let's take a look at the types of software packages. So I'm not going to look at Boolean modeling right now because that's what we're going to dive into when we start doing SolidWorks. So let's first go with NURB modeling. And even though you can do this in SolidWorks, I will show you the Cadillac software, which is Alias. So let me open up Alias. And when I use Alias, so a lot of my clients, and this is why I like to know multiple packages or multiple techniques. When I have clients and they come to me, and if they say, I need it modeled in this, I evaluate it and I say, okay, excellent. And I base my quote on how complex that is to model it in that software. You know, if they say, we don't care what you model it in, well, if I look at it and it's a complex surface, I'm going straight to Alias. If I don't have access to Alias and I have to do it, that's going to affect how much I quote the project on. Sorry, this is my biggest problem. There we go. Is remembering what software I'm in and what keys I'm using. So this is what I was talking about with splines. So it starts off as a straight line, but I can move it. I can get it whatever shape I want. I can bring in my sketch as a background and trace over my sketch. But really, what I'm doing is I'm moving in a complete free space. I don't need planes. I don't need anything to work on. I can create them, but they're not necessarily needed. So what I can very easily do is I'm going to pick this surface or this sketch. You can see V. I'll move it over to here. What I'll do is I'll do another sketch here. And what I'm doing is I'm controlling these all by these CV points to get that shape. And what I'm doing is it's called wireframe modeling. And it's very different than NURBS and T-splines. What I'm doing is when I say wireframe, it's because, as you can see, I'm creating a surface basically using basically creating the outside frame of what I want. So what I can then do is I can come in and I'm going to say I'm going to create a surface using these four shapes. So we'll go here to here. And now it's created a surface. Not a pretty surface. I'll also teach you how to build good surfaces and good curves. Because for a lot of you that struggled with surfacing last semester, I would fully expect it, because if you're not taught how to draw, it's like doing a marker rendering. If you have a bad sketch or a bad line work, your marker rendering is not going to look good because you're using that as a template. So same in this. If your curves aren't right, then your surfaces aren't going to be right, and it's going to lend you problems. So then you can see I've created a surface. If I want, I can edit it and change the form. You know, now I don't really have control over what's going on in here. It's a little bit of a struggle. So the nice thing is what I can do is I can come over here. Shoot, I entered into the wrong one. Bear with me. It's hidden. It's right there. I can turn on these points, and what I can then do, because I could have drawn another curve, or what I can do is I can start grabbing things and saying, well, I want that part to raise up. And now I'm very quickly getting a different form. Come on. I don't know why all of a sudden it wants to go so slow. Okay, so it didn't like the shading process. Now, when I show you how to do things in Solidworks, we'll talk about this a little bit. In Solidworks, in NURB modeling, so this is kind of that T-spline ability. You know, for me to create this using NURB modeling, I would have to draw a lot of lines and transitions, but I would be more accurate. This, very much more sculptural, freeform. You know what I think I want to do? I think I want this section to go down. I gotta turn that off. So that it tapers down and dives out. Now you can see here, it look ugly. I can go back and undo. So I know this is a lot of information. I'm just kind of doing a quick demo to show you. Any questions about kind of what we're looking at here that is NURB modeling and T-splines? No? Okay. So let's kill that. So that kind of covered T-splines a little bit. Let me show you NURB modeling, because NURB modeling is very similar to the T-splines. There we go. That's my biggest complaint about software packages. I don't know why they can't all keep the same mouse button combinations for zoom, pan, and rotate. But c'est la vie. So sub D modeling, basically what you do is you start with a generic shape. So we'll start with a sphere. We're going to make it big. And what you can see, come on. What you can see is, let me just go to shaded mode, is that this is made up into quadrants. What I can do is I can grab a quadrant and I can just push and pull it. So very quickly, come on, stop it. Very quickly, you can see all of a sudden I'm starting to get a form. Let me come in and I can come to this square or this section, and I can go in and I can say, you know what? I want to divide it more because I want more control. I don't want such a large mass moving. I want to have smaller parts moving. So there I've made more, and now what I can do is I can individually move these sections. You got to bear with me because I'm still learning sub D. Now, a good example of where things are easier is if you imagine, and I'll walk through this to give you an understanding another day, but a coffee mug. Doing the handle on a coffee mug can be multiple steps in SolidWorks or a solid modeler using NURB modeling. In this, it's probably about, 5 minutes of push, pull, drag, and then rounding it out. So things like that can be very much quicker in the different modeling packages. Questions? Nope. Boring? Exciting? Interesting?
It looks a lot nicer than. It looks a lot better than Solidworks, honestly.
Yeah. Yes. Now, if you're trying to do things such as shell, offset a surface, basically some of the other features, it would be a nightmare. Unfortunately, and I don't know why it hasn't, Rhino has not become an industry standard for 3D modeling for industrial designers. And I think part of that is when you hand off this model to an engineer, he has to rebuild it from scratch. Part of the issue with that is when an engineer or when somebody else rebuilds your model, there's a potential for design intent to get lost because it becomes a copy of a copy. And it depends on who's doing it. Someone like me who can do the solid modeling, can do the engineering modeling, but has an eye for form and an eye for refinement, I can bring forward the vision of the industrial designer easily enough. And there are some places, some clients that I do that for. They model it up in Solid or in Rhino. They come to me and they say, we need to give the engineer Solidworks model. I need you to build this. I build it. I go back. We talk about it. There's some things that I say, hey, look, in your model, you cannot do this. It's going to be a manufacturing nightmare and the engineers are going to yell at you. Here's what you might want to do. And then we have a conversation, well, what if? So that's kind of the benefit of knowing multiple packages. And yeah, the user interface looks much nicer too. Okay. So we kind of covered NURB modeling, T-spline modeling, and sub-D. Can you guys see that they're all actually quite different in the approach that you would do to create a shape? Okay. Let's close this out and let's get into SolidWorks. You know what? I need to just quickly run away from my desk. Let's take a quick 10-minute break, okay?